This is in continuity with the previous video. We are doing NCERT exemplar for polynomials. Now we are on question number 15. Now this question number 15 is based on this identity, that is x square minus y square is equal to x plus y into x minus y. You might remember it with a plus b as a and a minus b. Now we have to find the value of 249 square minus 248 square. So considering this to be a and this to be b, or you can take this as x and this as y, we can say it should be written as a plus b into a minus b, that is a, which is 249, plus b, which is 248, that multiplied by a minus b, that is 249 minus 248. So if I add 8 plus 9, that is 17, 8 plus 1, that is 9, and 4. And that is that multiplied by 1, so it's 497, which is D part is the correct answer in this case. Next question is question number 16. And in this question, we have to factorize it. Now we can see this is a quadratic polynomial. And we know quadratic polynomial can be factorized by different methods. Now, as of now, I can see that we can factorize this using middle term splitting. So we'll first multiply 4 into 3, that is 4 into 3 is 12. From the factors of 12, we need to split the middle term, that is 8x, which is 6 and 2. So we can write this as 4x squared plus 6x. I'm splitting 8 as x, 6x plus 2x plus 3. Now, common between the first two terms is 2x. So we have 2x as common, and we get here 2x plus 3. Likewise, the common between the last two terms is 1 only. So if I divide it by 1, we'll get 2x plus 3. So common from the whole is 2x plus 3. And then taking common 2x plus 1 from throughout, we get 2x plus 1. So we can say that 2x plus 1 and 2x plus 3, that is B is the correct option in this case. Next is question number 17. In this question number 17 is based on the identity. I've already written the identity. Now we can see that we can write x plus y whole cube as this and x minus y whole cube as this. Now we have to find the factors of this. So definitely first we will expand it and then we'll factorize it. So now I can write x plus y whole cube as this. That means we can write, let me first write down the question. This is x plus y whole cube minus, this is x cube plus y cube. Now check if we apply this identity over here, what do we get? We get x cube plus y cube irrespective of the order. This is 3x squared y plus 3x y squared. And if I open this bracket, it's going to be minus x cube and minus y cube. As you know that if you open this bracket, minus multiplied by all these terms. Now we can see that this positive x cube, negative x cube get cancelled. So is with positive and negative y cube. Now after factorizing, after reducing, we got this as 3x squared y plus 3xy squared. We have to find its factors. So clearly we will be factorizing it. And that is by taking common. We can see 3xy is common throughout. Dividing this by 3xy, we'll get 1x here. And dividing this by 3xy, we'll get y. So we have these as the factors. These are the two factors here. One is 3xy, another is x plus y. So we can see that out of the option given here, we have to find a factor, that is one of its factors. So the correct answer is D in this case. Now we have reached to question number 18 here, and this also is based on the identity. We have already written the identity, but let's understand what is the question here. The question says find the coefficient of x in the expansion of this. Most of you actually understand this and you write the coefficient of x as 1. Now, that's not correct because we need to expand this and then determine the coefficient. So we have x plus 3 whole cube. Now, applying this identity, here x is x and y is 3 here. So we can say that x plus y whole cube, that is a cube, plus b cube, that is 3 cube, plus 3a square b, 3a is x. So this is 3a square b plus 3ab square, that is 3, or you can take x also, 3ab square, b square is 3 here. Now x cube is x cube only, 3 cube is 27. This if I write, this is 3 into 3 is 9, right? So this is 9 times x square. And first this is 3 square, right? 3 square is 9, and 9 into 3 is 27. So this is 27 times x. This is 27x. Now, since you know that we have to find the coefficient of x, so clearly coefficient of x is 27 here. We say that coefficient of x in this case is 27, and therefore D is the correct option for this. We are on now question 19, and the question 19 is based on this identity. Identity on which it is based is this. Now, first I need to figure out what is the question. We are given x over y plus y over x as -1, and we have to get the value of x cube minus y cube. Now, what we know that x cube minus y cube is x minus y into x square minus xy plus y. So we need to convert this information which is given, right, in any of this form. Let's say if I first try simplifying this, what I can say, for simplification, we can take LCM. So this is xy divided by y is x, and x multiplied by x is x square, and so is y square is equal to -1. Further, if I transpose this xy to the other side, it will be multiplied with -1, and we'll get minus xy. Transposing xy to the left. Now you will be must be wondering why we are doing so. We are trying to obtain any of these, right? Say maybe this or this. So what I'm going to do here is I'm going to obtain this. So now what I can see, this is x square plus y square. If I transpose minus xy to the left, it is xy, and we are left with nothing, that is 0 on the right. Now, once we have done till here, now we'll say what we have to find out is x cube plus y cube. We have to get x cube plus y cube. So what is x cube plus y cube? This is x cube minus y cube is what we have to get. So we can apply this identity here. So x cube minus y cube is x minus y, that multiplied by x square plus xy plus y square. Now you can check here that we know the value of this. We know the value of x square plus y square plus xy, which is equal to 0. Now continuing with the working, what we can see here that this is x cube minus y cube is equal to x minus y. And as I said, we know the value of this as 0. So we get x cube minus y cube is equal to any number multiplied by 0 is 0. So if I see the option, it should be 0 as the option. So the option given is below. Yeah. So we have C is the correct option for this. Now, question number 20. This question is based on this identity. That is the third identity, what we say as a square minus b square is equal to a plus b multiplied by a minus b. And it is can be applied in the reverse order also. Now, if I first write on the question here, this is 49 times x square minus b square, sorry, b is equal to, this is 7x plus half, and this other is 7x minus half. Now check here, we have a plus b into a minus b, right? This is in the form of a plus b into a minus b. So we can write a plus b into a minus b as a square minus b square, like a square, that is 7 square, which is 49 x square minus b square. B square is half square, is minus 1 by 4. Now, if I write down the LHS, it is as it is. So this is b only, not b square. So if I reduce this, what we get in the next step is minus b is equal to minus 1 by 4. So if you cancel minus also, That means we get B is equal to 1 by 4. So on comparing the LHS and RHS, we get B as 1 over 4. Now we are on the last question from this section of this chapter. That is the first exercise, MCQ question. This last question is based on this identity, and it's a direct application of this identity. That is, if x plus y plus z is equal to 0, then x cube plus y cube plus z cube is 3xyz. So it's very simple to say that if x plus y plus z is 0, then x cube plus y cube plus z cube is equal to 3abc. That's a direct application. This is actually derived from the 8th identity, but we use it directly that whenever we find if x plus y plus z is 0, we can directly write as x cube plus y cube plus z cube is equal to 3abc. So this is the last question of this exercise. Now we'll continue to do more question, and we are left with quite a good number of questions in this exercise. That is 2.2 and it's there till 2.5. We'll be doing the remaining questions on the next video.